question number 41. A person cannot see beyond a distance of 50 centimeter. The power of correcting lens required to see the distant object will be. Here the person cannot see beyond 50 centimeter. So we can say that the person is suffering from myopia and he will not be able to see the object kept at infinity. So if some object is kept at infinity, then he will not be able to see it. But if he use a correcting lens, then he will be able to see the object. Now what will happen? The correcting lens will adjust the accommodation of the myopic person and the image of object kept at infinity will be formed at a distance 50 centimeter from his eye. That is why we will write minus 50 centimeter, because the image is formed to the left of lens. Now using the lens formula, we can calculate the focal length of correcting lens, given by 1 by f equals 1 by v minus 1 by u, which is equal to 1 by minus of 50 minus of 1 by infinity. So focal length comes minus of 50 centimeter. As a result, power comes 100 by focal length if we talk in diopter, which gives you minus of 2 diopter. So the power of correcting lens will be minus of 2 diopter. It means concave lens has been used here. Now let us proceed to the next question, that is question number 42. Question number 42. In Young's double slit experiment, the phase difference between two coherent sources of equal intensity is pi by 3. The intensity at a point which is at equal distance from the two slits will be, given that I0 is the maximum intensity. We know very well for such condition the resultant intensity is given by the expression I resultant is equal to I max, that is maximum intensity, cos square phi by 2, where phi is the phase difference. Now in question, maximum intensity is given, that is I0 cos of square. Phi has the value pi by 3, that is 60 degree, and divide will get 30 degree. Cos 30 root 3 by 2. If we square, we get 3 by 4. So the resultant intensity here will be 3I0 divided by 4. So this is our answer, and option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 43. Count rate of radioactive sample was 1600 counts per second at t equals to 0 and 100 counts at t equal to 8 seconds. Select the correct option. Okay, so this is the question given, having some option. Its count rate was 400 counts at t equal to 2 seconds. Half life is 2.88. Mean life is 4 seconds. So first of all, let us calculate the half life. Now, so this is the question. N0 is 1600 initially. After n half lives, the quantity remain is 100 counts. Now we know the very famous relation. The remain quantity after n half life will be n0 1 by 2 to the power n. After putting the values of n and n0, we will get n equals to 4. It means we can say that during the period of 8 seconds, 4 half lives has been done. It means for one half life, 2 second time must be there. So we got the value of half life. T half equals 2 seconds. Now the count rate was 400 at t equal to 2 seconds. Means at t equal to 2 seconds, one half life has been gone. So count rate must be half, that is 800. So this is wrong. We have to choose the correct option here. Half-life of sample is 2.88. We just have calculated the half-life, that is 2 seconds. So this is also wrong. The mean life of sample is 4 seconds. Now in order to calculate the mean life, we know that the mean life capital T is equal to 1 upon lambda, and lambda will be given by 0.693 divided by T half, that is 2 here. So we will get the value of lambda as 0.346, and as a result we will get T, which is equal to 1 upon 0.346, which never equals 4 seconds. So option number 3 is also wrong. Now we are left only with option number 4. The count rate was 200 counts at t equal to 6 seconds. At t equal to 6 seconds, 3 half-lives has been gone. So left amount is equal to initial amount 1 by 2 to the power number of half-lives, that is 3. So obviously we will get 200 counts. It means option number 4 is absolutely correct. So we will go with option number 4, and that is the answer. Now we will proceed to the next question, that is question number 44. The output of given logic gate is, we have to calculate the value of y, output of y. Now the question belongs to logic, the chapter semiconductor and logic gates. This is NAND gate and here is OR gate. Two inputs are connected with NAND gate, so it will give you the result A and B whole complement. On the other hand, OR is connected by two inputs. One is A and B whole complement and other is B. So OR does operation like, if we do A or B, it means A plus B, something like this. So we will get the result, one input is A dot B complement for the OR gate plus other input is B. So this is our y. Now we are not getting any option which includes this expression, so we need to simplify it. We need to apply the De Morgan theorem. De Morgan theorem states that if there is whole complement of AND operation of two input, then that will be equal to individual complement of them with OR operation. So A dot B whole complement will be converted by A complement plus B complement plus B. Now we know that A plus A complement or B plus B complement always gives us output 1. So expression reduced to A bar plus 1, and if we do OR operation with 1, then we always get 1. OR gives output high value every time if one of input is 1. So that's why 1 will be the final answer. So we'll proceed with fourth option, that is correct. So y equals 1. Now let us proceed to the next question, that is 45. A transistor is connected in a common emitter configuration as shown in figure. If VBE base emitter voltage is 1 volt and current gain beta is 100, then the voltage across collector emitter terminal VCE will be what? We have to calculate this value. VB is already given. This is grounded, 0 potential, this is 7. It means here we will get 7 volt. Here we are getting 1 volt. Now this is base. Suppose the base current is IB. Now we can write the value of IB as potential difference, that is 7 minus 1 whole divided by total resistance, that is 200 into 10 to the power 3. Solve it. 6 by 200 into 10 to the power 3. Ultimately we will get the base current as 0.03 milliampere. Beta is given. As a result we can calculate IC, which is equal to beta times IB. So we will get the value of IC as 3 milliampere. Now let us calculate VCE. Start traveling from this 7 volt written in the question on board and proceed toward collector. So if we apply the KVL, Kirchhoff's voltage law, we will get 7 minus of ICRC. We finally reached at VCE, so that is equal to VCE. So we will get 7 minus IC is 3 into 10 to the power minus 3 into RC is 10 to the power 3. That is equal to collector emitter voltage. So VEC or VCE, we ultimately get 7 minus 3, that is 4 volt. 4 volt is our answer, and we will proceed with third option. Third option will be absolutely correct. So this was the last question of physics portion, question number 45. Thank you everyone. Thank you.